As part of the senior design requirements for my combustion project, I had to design and then execute a test that answers a problem that was researched and identified earlier on, and that problem being a fire in a pure oxygen environment, and then looking at the moles of gas generated and the pressure spike that occurs with that. As part of the design process, I had to generate a materials list, procedures list, and then potential sources of hazard and error that were then reviewed by mentors prior to me completing this test. And what you'll see is, even with those reviews, as the initial testing was going on, it was more of a trial and error of ways to improve it before, in the end, a completed and final successful run of the test itself. The first few tests were a bit of a trial and error. One example is in test 1, when the gas ventilation tube had become submerged prior to the test. This went uncaught by us, and as the combustion process began, the pressure of the water was too great to allow gas to escape. This caused a massive pressure buildup in the can, which is very similar to what had happened on a much larger scale with the Apollo 1 fire. However, our can was able to avoid rupture due to having a blowout panel that was, in this case, the lid, that was able to pop and allow gas to escape that way. And Test 2 had a failure at ignition due to a bad connection, and so we waited a safe amount of time and then restarted with a good igniter connection for Test 3 using the same materials. Test 3 initially went off without a hitch. The combustion occurred and gas was being vented into the recapture canister. However, more gas was vented into the recapture canister than the canister could hold, and it forced the tube to be submerged again. While during the combustion, this was not an issue because the pressure was greater in the combustion chamber than in the water. However, just as soon as the combustion process had ended in the in the chamber, then water was able to rush back into that chamber. And as a result, one unintended benefit was that we got to see the paper immediately at the end of combustion. And having been saturated, when we took the lid off, there was no more combustion that could occur. And so you got to see exactly how much was burnt with the given amount of oxygen that was in the canister. However, due to the paper being completely saturated, it was unable to be weighed to see exactly how much mass burned up. And so all that's left is to visually analyze it. And with the gas recapture chamber being too big for the amount of gas that was vented into it, we could not get an accurate measurement of how much gas was actually created, generated, and vented overboard. Prior to test 4 beginning, we wanted to isolate the variables, and so we decided to go ahead and assemble a clamp stand to keep the recapture canister in one side of the catch pool, and then use a Swiss Army knife to be a weight at the bottom on the tube to help try to stabilize the tube and keep the tube in the recapture canister. And this would allow us to see if it truly was an issue in the canister not being able to hold enough gas, or if the tube was just moving so much and then becoming submerged, and it was different, and then that being the problem. So after assembling this, we were able to begin test 4, and test 4 showed the exact same results as test 3 of the chamber not being able to hold all of the gas that was vented, and then the tube becoming submerged and backfilling with water into the test chamber. And so that confirmed that with using one standard sized piece of printer paper, we were generating too much gas to actually be recaptured. And so at this point, we'd also ran out of oxygen and decided to go get more oxygen and then brainstorm some ideas for how we could come back and try to reassess the problem and get a successful test. And so that's when the night test began. As we got back, we began to reassemble the test station and reevaluate and make sure everything was safe to go for the next test. But this time, we'd be using a half sheet of paper. And as we used this half sheet of paper for the test, we ran 2 more tests that way. And so night test 1 and night test 2 is what they were called during the testing process. But night test 1 and night test 2 showed a little bit more promise. We saw a little bit less water getting into the tube, but it was still not quite perfect. And so at this point, we realized a half sheet of paper was just a little too much to truly get a full combustion experiment. And so with that, we went into the final test. And the final test that was using one third of a piece of paper. And so using that 1/3 piece of paper, we were able to get a full combustion and a full gas capture into the gas capture container, and actually get a complete end-to-end reading. Now, this end-to-end reading was very successful because it let us see, okay, we got the gas captured, and we've got a good and accurate weight before and after of the mass. However, one unintended benefit, as mentioned before, of the water bath and the water being reinserted into the chamber, is that it immediately extinguished the combustion process. So when you remove the lid, the new oxygen didn't reignite the paper. As we removed the lid from this final test, we had a small reignition of the paper, and that would have slightly affected the weight results. And so that is an error to take into account in the final results and analysis. But the kindling of that flame was very minimal and very easily blown out. Weighed them. It's 1.2 grams, if I remember right, but I got a picture of it. Above it, the line is bottom of the second dimple from the top.
Remember to close your valve this time. Alright, let's whip oxygen can. This is final test, 1/3 sheet of paper.
3, 2.
Yep, already bubbling out the bottom.
I didn't see a rush back.
It appears that we got away without any backfill this time. We definitely vented off the bottom of the jug when it shot up. But it looks like our backfill didn't happen this time, so this might have been a complete burn. Or an optimal burn, I guess.
Yeah. Let's see if we get it. But the paper comes out like a more. Oh, look at that. Let's see. There's a little bit of fire still going. So this one
Still burning.
Save. That part might get edited out of the video.
I would say that is our optimal ratio.
Yeah.